Hello, so in today's video, we're going to look at sketching some examples of cubic functions, so some examples of cubic graphs. I say the word simple here because in A-level maths, you're obviously, well, you're not going to need to be sketching ridiculously hard cubics where you can't factorize it. So what I really mean when I say the word simple is I just literally mean you can factorize it. So cubics you can factorize. So that's what you'll be sketching in your A-level maths course. So we got three examples here. The second one I've given a hint for. So normally with these kind of questions, you would have part A of a question where you have to substitute in a number. And then with part B, you can now sketch the graph after that. So that's why I've given a hint with this one there. And with question three, again, this is another cubic that we'll be able to sketch in a minute. Let's start with question one then. So sketching this cubic graph here. So we want to do the sketch of this graph. Okay, so the first thing to notice is that with these cubics, you'll always be able to factorize them. They won't give you a cubic that you can't factorize. So you want to factorize the x out there because every term contains an x, every term has a factor of x. So when you factor out the x, you get x squared minus x minus 12 in there. Okay, so can we factorize this even further? Well, yes, we can. So this is just a usual quadratic that we can actually factorize with two linear factors. If we put an x in there and an x in there, and then think about the factors of negative 12 that add up to make negative 1, well, that's going to be a plus 3 and a negative 4 because 3 times x makes 3x, negative 4 times x is negative 4x, so you get a minus x there, but you get a minus 12 from multiplying those two numbers together. Okay, so we've got the graph y equals this here, and we want to sketch it. So the key thing to remember is that cubic graphs, and I probably should have mentioned this at the start, I'll go to a new page for this. So when you have a cubic graph, for example, like ax cubed, so obviously cubics are in this form in general, ax cubed plus bx squared plus cx plus d. So when a is a bigger number than 0, then you're going to get a cubic with this kind of shape here in general. And when a is less than 0, you're going to get a negative cubic. So this graph flipped upside down. So you get something in a shape more like this instead. So the reverse, so basically the reflection of a cubic like that would be your negative. If you have a cubic with a negative a coefficient in front of your x cubed. So obviously that's something for GCSE just to bear in mind. So yeah, going back to the example then, we factorize it. The a is positive, so the coefficient there is 1. So your a value is positive. So it's going to have this kind of shape here. But what will the shape actually look like? So we can see if we just set this equal to 0. So if we set the expression there equal to 0, we can see we have three roots. So the roots are going to be x equals 0, because when you plug in 0, well, you get a 0 there, so everything just cancels out. So you get x equals 0, x equals negative 3, and x equals positive 4. So we get four roots from there, because again, when we make this equal to 0, we can see we've got three roots from these three linear factors there. So we get those three roots. So then now we can actually sketch the graph. So I'll just make the writing smaller. So then, yeah, sketching the graph, we've got x, the x-axis there, y-axis there, three roots. So at 0, negative 3, I'll just call that negative 3, and positive 4 there. So you're going to get this shape, this positive cubic shape, and it's going to look something perhaps like this. And that would be our graph. So y equals x cubed minus x squared minus 12x. So the key thing is look at the expression you get. Can you factorize it? Yes, you can. And then you can use that to get the graph from there. So that's the first example done. The second example, so this one here, we've got to use the hint with this one. So yeah, let's say you've got a question and then it says in part A, substitute in x equals 3 over 2, or maybe it says find f of 3 over 2. So maybe they call this f of x, and then they say find f of 3 over 2. So that's what you would do. You just plug in 3 over 2. So you get negative 2 times 3 over 2 squared plus 11 times 3 over 2 minus 2 times, sorry, I forgot the squared there. That should be squared, and that should just be x there. Sorry, apologies for that. So that should be 3 over 2 squared, and this is just 3 over 2 inside there, multiplied by the 2, and then subtract the 15 at the end there. So if we just tidy this up, negative 2 times by 9 over 4 plus 11 times by, sorry, I've done this wrong, 3 cubed. Again, that should be a cubed up there, my bad. 3 cubed. So 3 times 3 is 27. 2 times 2 is 8, so we get an 8 on the bottom there. 11 times 3 over 2 squared, so 9 over 4 with that one. Subtract, well, 2 and the 2 there cancel out actually, so you just get a 3 there. So just a 3 there and a minus 15 there. Okay, so we get minus 2 times by 27 over 8. Well, this is actually just going to be minus 27 over 4 because 8 divided by 2 is 4. So we get 4 there. And then plus, so 11 times 9 is 99 over 4. Subtract 3, subtract 15. And then 99 take away, so we've got a common denominator there, so we can actually just combine these fractions. 99 take away 27, well, that's going to give us 72. So we get 72 divided by 4, subtract 3, subtract 15. Now 72 divided by 4 should be 18. So 18 take away 3, take away 15. Well, that's going to give us 0. Okay, so we've got, when x is equal to 3 over 2, we know that we get a value of 0 from our cubic polynomial there. Okay, so now with part B of the question, so we've kind of done, let's say, the first part of the question. The next part, now we want to sketch the graph. Okay, so the key thing now to realize is that if f of x equals this negative 2x cubed plus 11x squared minus 2x minus 15, f of 3 over 2 is equal to 0. So therefore we can use the factor theorem. So therefore the factor theorem tells us that so 2x minus 3 is a factor of f of x. So remember, the factor theorem tells us that, I'll just do it up here in a box. So if f of b, or a over b, I should say, so a over b equals 0, that means that bx minus a is a factor. So that's from our factor theorem. So we know, therefore, that, yeah, so 2x minus 3 is a factor. So we can actually now look at factorizing the original polynomial that we've got. So we've got y equals negative 2x cubed plus 11x minus 2x minus 15. So this is just going to be equal to 2x minus 3 times by some factor that we don't know yet. So now it's just a guess of guessing what's going to go there in this missing factor. So again, we could either use long division for this, or we could just use inspection, where we guess which numbers go in there. So we need to make a negative 2x cubed. So if we put a negative x squared there, well, negative x squared times 2x gives us negative x cubed. Okay, so then now we can do, we can look at the final number that we've got here. So that should be a 15. So we want to make negative 15. We've already got a negative 3. Well, that's got to be plus 5 there, because 5 times negative 3 gets you negative 15. So the last thing in the middle, the x term, well, let's think about this. We want to try and make, sorry, again, that should be a squared there. We want to try and make 11x squared. Now, what have we got here? We've got 2x times negative x squared. Sorry, that's the wrong one. I meant this one here. So negative 3 times by negative x squared, that's a positive 3x squared. Okay, so we're trying to make 11x squared. We've already got 3x squared. We need an extra 8x squared. So we need an extra 8x squared when we multiply that with that. So 2x times something must make us 8x squared. What is that something going to be? Well, it's going to be plus 4x. So yeah, negative, so 4x times 2x gets us 8x squared. 8x squared plus 3x squared gets us the 11x squared there. So that's going to be an 8x, sorry, a 4x in there. So we now know that. Now, can we factorize this even further? Now, the problem is we've got a minus sign in front of the x there, which is kind of annoying. So let's factor out a negative sign from this factor there. So I'm actually going to rewrite it in a different order. So if I write it like this instead, times by 2x minus 3. Okay, now factor out a negative sign from that factor there. So we get a negative x squared, now minus 4x, now minus 5 times by 2x minus 3. Now, can we actually factorize this expression that we've got here, this quadratic factor? Yes, we can. So negative, and then in brackets, if we put an x there and an x there, what factors of minus 5 add up to make minus 4? Well, if we put a minus 5 in there and a plus 1 in there, that's going to work. So now we get x minus 5, x plus 1 times by 2x minus 3. And so, yeah, we get this, this factorization there. So we get a graph of y equals negative x minus 5, x plus 1 times 2x minus 3. Now, the key thing with this one, if we go back to our key results for the shape of the graphs here, is that if a is less than 0, so the coefficient of x cubed is less than 0, we get this negative cubic shape. So this graph has a coefficient -2. So let's make a point of this here. This is a coefficient of -2, which is less than 0. So we now need the negative cubic shape. Again, if I just move everything to the side over here, I'll move this there. Okay, so we've got a negative cubic shape like this. So we've got y-axis there, x-axis there. Now, if we think about our roots to start with, though, so if we set this equal to 0, what will our roots be? Well, x equals 5 is going to be 1. Plug in 5 into that one, we get 0. We've got another one at -1. Plug in -1 into that, we get 0. And then we know from a fact we've got a root actually at 3/2 because we actually worked that out. So we've got 3/2 as a root as well. So we've got -1 there, let's say 5 over there, and 3/2 somewhere perhaps here. -1, 3/2, 5. So it's a negative cubic shape because of the negative coefficient, the -2 there. So it's going to be something like this instead, something like perhaps like this, going through all of our roots like that. And so that would be our sketch of our graph, -2x cubed plus 11x squared, -2x, -15. And actually this y-intercept there would be a -15. I mean, it's not a very good scale, but that should be -15 there. So that's our second example done. And then our last one, so y equals -x cubed plus 10x squared minus 25x. Okay, so again, the key thing you want to think of is, can we factorize this? Sorry, there should be an x there again. Yeah, we can factorize it. They all contain an x. So bring an x out. Actually, I'm going to take a negative x out again because of this negative sign in front of the x cubed there. It's just easier to get rid of this minus sign in front of your largest power of x. So we get a negative x, and then in our brackets, we're going to have an x squared there to make the negative x cubed. We're going to have a plus 10x there and a negative 25 in there. Okay, so now can we factorize this even further? Again, yes, we can. So in A-level maths, they're always going to give us questions where we can factorize even further. So let's think about this. Let's put an x in there and an x in there. What factors of -25 add up to make 10? Well, if we think about it, sorry, I forgot. This should be a plus sign there. I've made a mistake here. Sorry, this should be plus, and this should be -10x. Sorry, my bad. So obviously, yeah, you want to factor out the minus sign, so that becomes a minus sign, and that becomes a plus sign. Apologies for that. So yeah, what factors of 25 add up to make -10? Well, that's going to be a -5 and a -5 because -5 times -5 is 25. -5 take away 5 is -10. So yeah, that's going to be our factorization. I can actually write it a bit more neatly like this. So -5x, sorry, it's -x times by x minus 5 all squared. Okay, so how are we going to sketch this graph? So the key thing to realize here is that we only have 2 roots with this one. So we have 2 roots instead of 3. So we've got a root at x equals 0. So again, make this equal to 0. We've got x equals 0, and we've got x equals 5. So when you square a linear factor, so this factor there, the root that results from this factor, this would be called a repeated root. So this is a repeated root. So you would have seen repeated roots in GCSE, perhaps, when you sketch graphs like, for example, y equals x minus 4 all squared. So when you sketch a graph like this kind of quadratic, you would get a root here at 4, but it's only, the quadratic is only going to touch at 4. And a sketch of a function, a graph which touches on the x-axis at a point, that is still a root because a root is just where the graph meets the x-axis. But it only meets, it's only tangent to the x-axis, just a tangent to the x-axis. It doesn't actually pass through the x-axis. So a root whereby the sketch only touches the x-axis, this is called a repeated root. So repeated, I haven't spelled that right. Let me do this again down here. So repeated root. Okay, so we've got a repeated root there, and we've got a repeated root at x equals 5 here because of the squared. So when you so repeated, the word repeated basically because we're repeating this root there and there. We've got a root 5 there and a root of 5 here as well. So we're repeating the root. So that's why what we mean by repeated root. So we're squaring the linear factor, which gives rise to this root here. So if we sketch this graph, we've got to be a little bit careful with this one, just because we need to make sure that the root at x equals 5, our graph doesn't pass through that root, but it touches the root. It's basically a tangent to the root. Let's try and sketch this. So we've got roots at x equals 0. So this is a normal root. This is what we call a simple root. So this is a simple root. So a simple root is just like the roots we've had in our previous example. Sorry. So these are all simple roots here, and these are all simple roots here and here and here, because we have just linear factors without squaring them. So we've got a simple root there of x equals 0. So the graph is certainly going to pass through that point. And we've got a repeated root of 5, so 5 there. So yeah, what will our graph look like? Again, the key thing to realize is that we've got a negative coefficient of x cubed. So the a value is less than 0. So it's going to be a shape like this here. So again, it's this negative shape. So what's going to happen is it's going to start from, it always starts in the bottom right corner. So it's going to start from the bottom right corner. And then we can't, because x equals 5 is repeated, we cannot go through like that. We must just touch it. We've just got to touch it like that. And then the shape is going to go down again because cubics do this. They go down and up and down and up again. It's going to go down like that. And then it's got to pass through here because this is a simple root. The graph must go through a simple root. So it must go through like that. And so you get a sketch like that. So this is the graph y equals negative x cubed plus 10x squared minus 25x. So that is the sketch of the graph here. So yeah, this was just a video to basically summarize how we can sketch cubics like that. You'll probably need to sketch these kind of graphs or use these kind of graphs to help you out with some questions. But yeah, the key thing to bear in mind is that you'll always be able to factorize the cubics that they give you. I mean, you could use your calculator as well to get the roots. You can use that as well. That can help you out. But the key thing is that if you've got a simple root without, for example, here, when the linear factors are not squared or cubed, then these are simple roots. The graph must go straight through those roots. If you have a repeated root like this one here, where you're squaring the linear factor, you're repeating the root, then the graph only touches through that. And you can use some graphing software to see that that is actually the case. And you also know from GCSE maths that this is the case with quadratic graphs, like that there. So yeah, again, any questions in the comment section, please do let me know.